Good day everyone, welcome to this video and welcome to this episode. In today's episode I would like to show you a interesting task, which is how we can find the shortest path between 2 points, for example a bus depot and a bus station. We could think about this task as solving a two-dimensional maze, where we could use different type of maze-solving algorithms. But as you see this map, we have a little problem. This is not a two-dimensional maze. We could imagine this as a 2D maze, but the fact is that we have bridges, and we have roads under these bridges, and maybe we will have tunnels also in the future. So we might say that we have multiple layers of roads, and most maze-solving algorithms store and use a flag whether a field was already visited or not. And as we can have roads under a bridge and even a tunnel under a road, or maybe both of them, well, we may end up several times on the same coordinate. And if we have multiple layers, well, this might not work very well. So how can we solve this problem? We may think that because of these layers, it's a very hard task. Actually, it's pretty easy. And now I will show you how we can solve this problem, and you can easily add this to your own program if you want, because it's relatively easy to implement. So let's see this map, where let's say we have a starting point and a finishing point. Let's call these point A and point B. When we think about this task, to find the shortest path between these points, we may see that when going from point A to point B, we will have to go through turns and junctions. So some special fields where we can or where we have to change our direction. So first I wrote an easy function called collect junctions, which collects these special fields into a list, or basically an array. Then I wrote another function which can check whether we can go from any of these fields to another field. As we can move only along the x and z axis, it's pretty easy to check if we can reach one point from another. We just have to check each neighbor cell. We can also add a code to this which can tell us the distances between these fields. And basically we got rid of the multiple layers, because viewing this diagram, it doesn't matter if these fields are on the same layer or not. What matters if we can reach any of these from another one. When I got to this point, I realized that somewhere in my studies I saw something similar. When we studied as a computer science engineer at the university, we saw something similar when we learned about the shortest path algorithm in computer networks. And I immediately remembered the Dijkstra algorithm. So adding the starting point, point A, to the beginning of our junctions list, and adding the finish, point B, to the end of the list, and then running the Dijkstra algorithm on this, we can easily get the shortest path between these 2 points. And this is how simple it is, even if we have multiple layers. And as you see, the whole algorithm is just 45 lines, even if I added some extra, because if we define a route for a bus or truck, we of course have to run this algorithm multiple times. For example, from the first station to the second, then from the second to the third, and so on. Of course, with the help of this we can define unique routes. So for example, if we want, we can go around in a circular path. So if we don't want to use the shortest path, for example, I hope you like this little video. If you want to see similar videos in the future, just feel free to subscribe. Thank you. Bye bye.